Hey guys, this is Mr. Krieger. We're doing lesson 5 today from Unit 9 on trigonometry. The specific lesson is angles of elevation and depression, and we're also going to see how to set up problems where the diagram is not given if you're given a word problem. Okay, so first of all, take out the lesson. The angle formed from looking, well, let's talk about what the angle of elevation is. So let's say you're here on the ground, that's a little person, and you're looking at a bird. So you have to kind of look up. Now normally you look straight across, but since you have to tilt your head up to look upwards at the bird, that is the angle of elevation down there, okay? So it's the acute angle at the bottom of a triangle, not the right angle, which is at the bottom of the triangle. It's the acute angle because basically you're elevating your head to see the object up there. That's the angle of elevation. So if you see that, that's where you would put the angle measure. Now the angle of depression is sort of like this. Let's say you are up here. Let's say you're flying in an airplane. So I'll make a little airplane here. Okay? And you're looking down at the ground. Now normally your eyesight would go straight across. Normally you'd be looking straight across, but now you've got to kind of depress your head so you could look downwards. So this angle out here is the angle of depression. Okay, so we put it in there and made it a 36-degree angle. So you're looking at the ground at a point over here. And this is the angle of depression. Well, what's interesting is even though the angle of depression is out here, you could actually also put it inside your triangle down here. And that's because those angles are alternate interior angles. And the reason you would want to do that, if you notice the angle of depression, it's not in the triangle that you want. The airplane is a certain height off the ground, and it's creating this triangle. But the angle of depression is actually out here. But this angle here isn't inside the triangle, but we know this fact about alternate interior angles, so we could take the same measurement and put it there. So essentially, you can think about the angle of depression as in the same location as the angle of elevation. They're essentially in the same spot for a different reason, but they're in the same spot. So if you see the word angle of depression, you want to make your triangle and put the angle of depression at the bottom of your triangle, not where the right angle is, but in the other acute location at the bottom of the triangle. You don't even need to really draw this exterior part. You could just make your triangle and put your angle measure down there, okay? So really, angle of depression, angle of elevation depends on what your point of view. If you're looking from here upwards, this is your angle of elevation. If you're looking here downwards, this is your angle of depression, and you see that they're alternate interior angles. So that kind of makes it easy as to where you should put the angles. And you should always really put them into this location, even if you're given the angle of depression. So now we'll try a problem out. Okay, so here's what we have. Gabby is on a boat that is approaching the shore. Gabby's boat is 305 feet from the foot of the lighthouse on the edge of the shore. If she looks up to the top of the 160-foot lighthouse, what is the approximate angle of elevation to the lighthouse? Okay, so here's Gabby's boat. We'll draw a little diagram of her boat right here. Okay, and she's looking at the top of this lighthouse. So the lighthouse is over here. LH for lighthouse, right? Now let's make a triangle out of this. So here from the boat to the bottom of the lighthouse, and then Gabby's looking up to the top of the lighthouse, and let's put in what we know. It says that her boat is 350 feet from the foot of the lighthouse. So here's Gabby, this is the foot or the bottom of the lighthouse, and that is, 305 feet, not 350, but 305 feet. And it says the lighthouse is 165 feet tall, so we put 165 there, and it wants to know the approximate angle of elevation to the top of the lighthouse. So we could put an x or a theta in here because this is where the angle of elevation would be right in there. Okay? So now it's just a regular right triangle trigonometry type of problem. If this is the angle we're looking for, then this side is the opposite side and this side is the adjacent side. And when we're doing opposite and adjacent, let's write out this word, SOHCAHTOA. Opposite and adjacent is coming from tan. So we'd say tan of theta equals opposite over adjacent. So we could say tan of x equals 165 over 305. And now you know we've got to use that special inverse function, either the second tan, or if you're doing it on the GeoGebra calculator, you'd be hitting that button tan -1. And you type in that fraction 165 divided by 305, which gives you 28.4126 ... Since we have to round this to the nearest degree, that's going to be 28 degrees. Okay? So that's how you solve a problem like this. And here is a procedure that you would use. Tips for solving real-world trig problems without a diagram. First of all, decide if the problem is about angle of elevation or depression. Either case, remember, you're going to put that angle here. Try to plot the vertices of the triangle using your knowledge of angle of elevation and depression and draw in the right angle. Okay? So if your angle of elevation is here, then you would be drawing the right angle here and finishing off your triangle. If your angle of depression is here, here is your triangle, right angle here, and you're going to put the angle of depression into the triangle down here at the bottom of the triangle. Okay? Set up your equation with a trig ratio and solve it like we've done in the last few lessons. So that's how you would set up these word problems. Okay, so let's practice some more of these types of problems. Okay, Rachel is holding a kite with a string of 106 meters long. The kite's altitude above the ground is 84 meters. What is the angle of elevation of the string to the ground? Assume that the kite string is taut, so that's pulled tight, so there's no slack in it, okay? So let's see what's happening. Rachel is holding a kite. So let's say Rachel is here, and she's holding onto a kite, which the wind is blowing the kite, so the kite is going off like that, right? And it says the kite's altitude above the ground is 84 meters. Now, this distance is not the 84, because that's not an altitude. An altitude is a line straight up and down. That's going to be 84. We're going to finish the triangle here, and here's where the right angle would be. That's the kite. This is where Rachel is. I'll call it R for Rachel, right? We know the string is 106 meters long, so this is 106. It says, what is the angle of elevation of the string to the ground? So we know the angle of elevation is going to be down here, so we put an X here, and now we could figure out what kind of trig ratio to set up. This side is an opposite side, and this side we know is the hypotenuse. And when we take a look at SOHCAHTOA, the side with opposite and hypotenuse in it, the trig function with opposite and hypotenuse is sine. So we would do sine of x equals 84 opposite over 106 hypotenuse. And again, we're looking for an angle, so that's when we use the inverse sign, sine -1, second sign on your calculator, and you type in the fraction 84 over 106, which gives you 52.4153 ... And this says round to the nearest tenth, so that 1 is going to cause that 4 to stay 4, so we get 52.4 is the measure of that angle of elevation. Okay? Okay, next problem. Ariel was looking out the 4th floor window of her friend's yacht. So this obviously is a giant yacht, probably like a cruise ship. So she's, let's say, up here looking at her 4th floor window, which is 40 feet above the water. While looking out the window, she noticed a sailboat out in the distance. So she's looking out here at a little sailboat. Okay? And the bottom of the boat appeared to make a 35-degree angle of depression from where she was standing. Now, Rachel is looking down at the boat, right? And, you know, we know the angle of depression would normally be out here, and it would be 35 degrees. But we also know that you could put that 35-degree down here inside the triangle, where the right angle is going to be over here. Okay, so now how far away from the base of the yacht was the boat here? So how long is this distance? That's what we're looking for right here, okay? So again, we'll go back to SOHCAHTOA. We see this is the opposite side and this is the adjacent side. Opposite and adjacent is 10. So we would do 10. And this time we're not looking for the angle. Since we have the angle, we put that right next to 10. We don't have to use the inverse here because we know the angle. And opposite is 40. Adjacent is the missing side. Put this over 1 so we could cross multiply. Okay, and then we're going to divide by tan 35. If you're going to put this into your calculator, you want to make sure that angle is in parentheses. So we're basically getting, if you're using GeoGebra, it's going to be 40 tan 35. Put this right into your calculator like this, which is 57.1259 ... And since we're rounding to the nearest foot is 57 feet. So this distance down here is 57 feet. Okay? Now I'm going to take a look at the last question. There's some additional element to this problem which we'll take a look at, which makes it slightly more complicated. Actually, there's a couple of things here that complicate it. It's more like a Regents type of question. Let's take a look what's happening here. To determine the height of a tree, loggers will measure the angle of elevation to the top of the tree from a set distance from its base. So the logger is standing here, he's looking at the top of the tree. Now here's the thing, the logger's eyes are, for where he's looking at the top of the tree, is 5 feet 3 inches. Okay? 5 feet 3 inches. That's how tall the logger's eye point of view is, right? So that's 5.3 inches above the ground, and the angle of elevation to the top of the tree is 38 degrees. So there's a 38-degree angle of elevation. And he's standing 25 feet from the base of the tree. So from where the logger is standing to the base of the tree, that's 25 feet. Determine the height of the tree to the nearest inch. So we're looking for the height of this tree. Now the problem is, since his triangle is starting from the point of view of his eye, what we're really finding in this triangle is this distance here. That's going to be x. And then what do you think we're going to have to do to get the total height of the tree if we're going to be finding this amount in our triangle with the trigonometry? We're going to have to add on this extra bit, 5 feet 3 inches after we find x. Okay? So basically that's what it is. So I'm going to put the 25 inside on the triangle here. 25, this is x, and that's a 38-degree angle. So this is going to be a straightforward trig problem. Opposite over adjacent is going to be tan. Tan of theta is opposite over adjacent. So now we're going to put in what we know. We know tan of 38 equals opposite is x, adjacent is 25. Put this over 1 and cross multiply. We're going to get x equals 25 tan 38. We're going to want to put that in parentheses. And we get this number is 19.53214066. Now here's the thing. This is not in inches. This is a little more than 19 and a half feet. Okay, a little more than 19 and a half feet. Probably 19 feet and 6 inches. Now we want the thing in terms of inches. Actually, we could do feet and inches. So it might be 19 feet and 6 inches, but I got to make sure this 0.53 isn't maybe 7 inches. So we're going to have to convert this part right here into the actual inch equivalent, because right now it's in a foot amount. This is a foot amount. So we have, this is 19 feet. This is the extra part. This is in feet. We want to convert to inches. So we're going to make a proportion here where we're going to say this. This portion, which we want to turn into inches, is in feet. Now that is to 1 foot, as I'll make a new variable y, as y inches is to 12 inches. This part of a foot is to a whole foot, as this many inches is to 12 inches. cross multiply this and we get y equals 6.385687952. To the nearest inch, it's going to be 6 inches after all, right? So what we get is the x value is actually 19 feet and 6 inches. And now remember, we found that this amount is 19 feet 6 inches. Now we're going to have to add on another 5 feet and 3 inches. And we get that the tree is going to be 24 feet and 9 inches. Okay? So work on homework number 5.